You see? Take this old lady, 100 years old, she has osteoporosis. But she does not only have osteoporosis. She cannot hear well, she cannot see well, her muscles are weak, she has a high risk of falling, which is very important. Funnily enough, I mean, I as a layperson discovered doctors don't understand falling. And falling has such a big impact on whether you break your bones or not. And the colleagues at Charité in Berlin developed prognostic methods for this, and they can now predict to, let's say, 83% specificity whether you might fall or not, which is already big progress to better understand what's going on. And these are kind of the data you have to put into your models. And of course, all these aspects today doctors cannot integrate. We don't have evidence-based medicine on this. Evidence medicine is based on pill A or pill B, intervention A or intervention B. But with older people, more multimorbidity, new disease profiles are developing, and we just have absolutely no information how to deal with this. So the advantage for us was that the modeling bones is a relatively simple process. As I told you, the big model we have still takes weeks to run, and the reduced model takes 4 hours to run on the Italian supercomputing center. The supercomputing center is part of the project. But we are getting there, yet you might get information. Oh yeah, this is just the model. You see the various parts of the model. The model is not just one model, it consists of many submodels. It is an integrative model or hypermodel or however you call this. And all the different aspects have to work together. So here we have on the one hand side the body level model. You have to understand the whole body, the forces you put on your muscles and on your bones and so on. Then you have to model this specific bone here, the femur. You have to understand the tissue level model. Here again, the tissue level model colleagues in Zurich developed based on mice, osteoporotic mice. They did experiments with mice, which you just can't do with a human being. But they can now simulate how even in osteoporotic human beings, the bones dissolve and are rebuilt. They, for instance, found out through this mice modeling, the best method against osteoporosis is walk, walk, walk. Put strength on your bones. Keep your bones moving, and this will help even in old people to rebuild the bones. You have to go down to the cell level to understand the cellular processes, where also medications, drugs operate. And the constituent level model is that you need kind of an abstraction just to calculate certain properties of bones is so, probably say, intensive that colleagues in Eindhoven built about 20 typical bones here, which you put into these models, because you can't do this for every person individually. You have to adjust, find out which is closest to this person you have in front of you, because otherwise the simulation mathematics just explodes. So, and then you have to put all of this together, and to show you the next picture, then in the end, and this is just the surface, you have this kind of complex components of various mathematical models which report to each other, which feed back and so on. And I think this starts to tell you the whole complexity of these simulation models. I'm not going to go into this. I don't understand this, quite frankly. I'm not a mathematician here. But this gives you an idea why this is so complex. But this is an attempt, and a relatively successful attempt, to make some progress here. And here they are coming back to this lady. The virtual physiological human technology is an attempt to simulate, indeed, the situation of this old lady and not of another lady, and to be able to predict disease progression and impact of treatment. See, we had options that you might just do nothing. The risk is low. Right now, we cannot predict the risk really. There is a model to predict risk. but 50% of these people who are supposedly osteoporotic do not break. On the other hand, where doctors think these people have no risk, nevertheless up to 50% break. And just to improve the risk prediction a little bit will already make a big advantage, because we treat the right people with the right interventions and do not treat the wrong people. Today a lot of people are wrongly treated because we don't understand this. Okay. Yeah, okay, the final aim is, as I mentioned several times, to improve prevention, to improve prediction, and to improve treatment. And the last item here is perhaps very relevant. As I mentioned earlier, also try to use these kinds of simulation models in drug development or other clinical trials. The idea is to substitute, let's say, experimentation with humans, do not harm, to go into these simulations. Okay, let's fix this. And this is my last slide. I just like this, so I present this to you. This is from Stephen Hawking. Hawking in a lecture on Gödel and the end of the universe. This also kind of course gets us back to Douglas Adams, the universe and all of it. And I don't know who of you are familiar with Gödel's theory, but Gödel, he was a, how do you say, logician, philosopher in Vienna. He kind of destroyed the hope of 2,000 years of philosophical thinking that we could find the one single formula to understand the world and kind of to solve all of our issues. And he proved that an internally consistent system cannot be built kind of internally. We always need some assumptions. Like our mathematical systems, 2 and 2 are 4. Bertrand Russell showed at least on 2 assumptions we have to agree, otherwise we cannot build our perfect mathematics. And you could have, if we agree on other assumptions, a totally different system of mathematics. So we cannot prove it in itself. And I think the important thing is here, a finite system of axioms is not sufficient to prove every result in mathematics. And Stephen Hawking kind of translates this as a corollary. He said, our search for understanding will never come to an end. Logically, we can prove it can never come to an end. And we will always have the challenge of new discovery. And I think this is also what a conference like this is about. Let's work together, enjoy the discourse, and yeah, have fun. I always think this has to be fun. It's hard work, but there's always the option of finding new information and new knowledge and new cooperation. So, and I have to add this here because lots of this is based on European Commission funded research. And of course I have to tell them, this is my opinion, this is my belief, my results. And for Christ's sake, don't go to Brussels and tell them, oh, this guy has said in your name something. Okay, thank you very much. Could any